Hello dear students, welcome to today's class. So today I'll be starting with the chapter that is digital electronics. So in the digital electronics, first I will be starting with the two major branches of the electronics, we can say. Otherwise, the major categories or parts of the electronics, that is analog and digital. What is analog and what is digital? And in digital, what all you have to study here, entire thing I'll be covering here. Okay, so coming to the electronics is basically studying the electronic devices and their utilization. So here in electronic devices, you will be coming across analog type of electronic devices, digital type of electronic devices, analog systems and digital systems. What are analog systems? What are digital systems? And also you will have to study what is the difference between basic difference between analog representation and digital representation. After that, I will be moving with the digital part. Okay. So here, I just want to highlight few differences in analog and digital that you are observing in your day-to-day life. That is the most simplest example is the analog watch and the digital wristwatches. Okay. Otherwise, even the wall clocks. Otherwise, normal desk watches also. Okay. So analog, which will be having the needle representation. Okay, over the scale, the needle rotates to represent some time. Otherwise, the value that represents the exact time at that moment. Okay. In the digital form, what happens? The time in terms of AM or PM will be simply displayed in the form of numbers. Okay. So in this case, what happens, which will become more easier for observation, is definitely digital form. That is the importance of digital electronics. Otherwise, the word digital itself. Okay. Digital has become a very important word in our daily life. We almost use it in our daily life without even realizing that. Okay. So here I'm going to speak more and more about digital, and I have given only one example here, and we are also having many other examples. That is, previously we used to use the radios, where we used to rotate the knob to select a different station for listening the radio. But now we can just enter the frequency, that is, for example, 93.5 if it is, then we will just enter that in our mobile itself to listen to the radio. But previously it was to be tuned. We used to tune it because it was a analog system that time. Okay, that particular radio set was an analog system. Now those radios are available in the mobile itself, where you will simply enter the number that is in the digital form to access that radio station. Okay, this is one example. And apart from the digital and analog differences, you can also see in your vehicles, that is the two-wheelers. Previously you used to observe the needle that is the speedometer, that is going to indicate the indication for the fuel as well as the speed of the vehicle. Okay, there was a needle that was rotating on the scale for the speed, that indicates the present speed of that particular vehicle, and also it indicates the fuel present in the vehicle. But now even that has become digital. The speed will be displayed in the form of numbers, and the availability of the fuel inside the vehicle is also represented by the numbers itself. So this is the I just want to tell you the importance of the digital. Okay, everything is becoming digital now, right? Apart from this, we come across many other examples. Okay, and previously very old televisions, before the remote, there was also rotating knob for selecting the particular channels, and previously there were hardly two channels. Okay, now with the access of the remote, you can use otherwise you can view as many as channels you want. Okay, it is just a number away. You have to press a number to access a particular channel. Okay, so digital Electronics. Introduction to digital electronics. Introduction to digital electronics we are going to study now, where I have told you that I will start with the analog and digital differences first. Okay, I will write the two systems available, analog systems. So totally what we are studying here, we are studying the systems, otherwise the circuits or the what we can say devices which are available with us. Okay, so I am writing about the systems, that is analog and digital systems. Okay, the basic difference between the analog signal and digital signal is that analog signal continuously varies with respect to the time. Okay, with respect to the time, it is continuously flowing. Otherwise, it is continuous in its nature. Whereas digital will be having only two distinct values. Okay, two distinct values. Where it will be only switching between those values to represent a particular number. Okay, analog systems, the systems process the signal that continuously varies over time. Continuously varies over time. Here I will be giving you one example. With respect to time, the quantities we can represent here is voltage, current, or power. Any quantity can be represented here. That means the voltage is continuously changing with respect to time. This type of signal is called as analog system. Analog signal. I will take another example, that is the triangular wave. It is just depending on the wave shape. The wave shape here is triangular, that is it is called as triangular wave, and this is called as the sinusoidal wave. Okay, but the basic point is that it is continuously varying in nature. It is also continuously varying. For every instant of time, it will be having a different value. Okay, and it is continuous in nature, that will be continuously flowing. Okay, this type of signals are called as analog signals, and the systems that process this type of continuously varying signals are called as analog systems. Okay, so this is about the analog systems, and analog signals also I have told you analog signal continuously varies with time. Continuously varies with time. Okay, continuously varies with time. So this is the example for analog signals, and this is the analog system. So totally, and I would also want to highlight, otherwise I would also want to cover a point that all the signals that are available naturally are all analog. Okay, voice continuously varying signal, temperature, heat, pressure, all the natural signals are analog in nature. That means they change continuously with respect to time. So all the signals are what? Analog in nature, right? But what we have, the present era, all the systems are digital systems. Okay, all the systems are digital signal systems, but all the signals that are naturally available are analog signals. Okay, that's why we need to understand the concept of analog as well as the concept of digital. So now about the digital. Digital systems process Digital systems process discrete values. Sorry, discrete values. Discrete means what? Two different values, otherwise multiple different values. So here the representation will be in terms of numbers, otherwise in terms of specific symbols or specific values. Process discrete values. Digital systems process discrete value. Discrete means which will be having different values. About the digital signal, it represents two symbols or switches between two possible values. Okay, digital. Otherwise, which will represent numbers. We can say. Digital means which will be having digits naturally, so it will be dealing with the numbers, right? It will be having only two types of signals. Okay, this is represented by 1, this is represented by 0, this will be represented by a different voltage level, and this will be represented by a different voltage level. So here the values will only switch between two different voltage levels. Okay, and here the voltage will be continuously varying. This is about analog systems and digital systems. I have given you many differences between analog and digital also, continuously varying and discrete. It will be having discrete values. It will process only discrete values. The values will be having different voltage levels. Okay. So now moving further with the digital technology, otherwise the digital systems or signals, I would like to discuss about the most important what we can topic is the number systems. Okay, numbers you are already aware of because you have studied mathematics, where you have seen the counting of the numbers, adding, subtraction, everything. You have performed many and many operations with the numbers. Here in the number system, we will be studying what are the numbers that the digital electronics, otherwise the digital systems support. Okay, upon which numbers the digital electronics works, right? So here we are studying what now? Number systems. Digital electronics works, otherwise the digital technologies work on many and many number systems, but here we will be focusing on the main types of number systems. So here the number systems which will be studying here will be basically 4 number systems will be studying here. Decimal, binary, hexadecimal. Okay, the number systems: decimal number system, binary number system, octal number system, and hexadecimal number system. About this decimal number system, everybody will be aware of because we are using it in our daily life. Okay, it will use the representation of the numbers from 0 to 9. Okay, and any number you can form from 0 to 9. Okay, for example, the number 124 is formed between the numbers available with 0 to 9. 0 to 9, there is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The combination of these 10 symbols. So total how many symbols are there? Starting from 0 to 9, there are total 10 symbols. Using these 10 symbols, we can form any what we can say combination of the number. We can form any number of digits, any digit value. Okay, we can make a 3-digit value. We can make a 20-digit value. Okay, as many digits as we want, we can form from the 10 basic symbols, and the 10 basic symbols are 0 to 9. That is starting from 0 to 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, I've taken example of 124. We can also make many decimal numbers. A 2-digit number may be 18. Okay, 1 and 8. 1 and 8 fall between 0 to 9. So totally from these 10 symbols available, we can form any decimal number. Okay, this is the decimal number system is the most commonly used number system in our daily life. Okay, in our day-to-day life, because we have been practicing it from years and years. Okay, we have been practicing the decimal number system. We use it in our daily life to exchange the money, to pay somewhere, or even to count the number of things we are having. For example, if we are having books, to count how many books we are using the decimal number system. Okay, to count the money we are having, we will use the decimal number system. If we want to spend some money, we will count using the decimal number system to pay for the service we have taken. Okay, so totally the decimal number system is the most commonly used in our daily life. Okay, but it is different for the digital systems. For example, even for the computer level, or the digital level, all the digital systems follow the next type of number system, that is the binary number system, which will be having only 2 symbols, that is 0 and 1. The binary number system uses only 2 symbols. It understands only 2 symbols, 0 and 1. It does not understand 2, 3, 4, 5, 6, 7, 8, 9. Okay? It is not going to understand the other symbols. It understands only 0 and 1. Right? So decimal number system will be having 10 discrete symbols, that is from 0 to 9. From these, we can form any decimal number system, the most commonly used in our daily life, because we have been practicing it from years and years. Binary number system, that the digital systems use internally. Okay, basically for storage of the memory. Whenever you store something in the memory, the complete thing, maybe a picture, maybe a video, maybe a music piece, that is broken into the zeros and ones while saving in the memory. So when it is inside the memory of your mobile or inside the memory of any chip, the information may be image or any text message or anything, that will be broken into what? Finally, inside the memory, what is stored is in terms of zeros and ones. Inside the memory, you can only find zeros and ones. Okay. So these are the 2 basic units, that is decimal number system that the human understands, and binary number system that the digital system understands. Okay, so these are the 2 major number systems. Coming to these 2 number systems, these are the supporting number systems that are used to represent the numbers. For understanding of the designer, these 2 number systems are developed. Otherwise, these 2 number systems are practiced to represent the binary numbers that are suitable for the designers. Okay, so these two number systems are very important for the designers or the engineers, right? Because when we are representing the number in terms of binary, sometimes the number becomes very, very, very large, otherwise a very lengthy number. So to represent that lengthy number, we use the hexadecimal number system that will, what you can say, reduce the length of the number, but does not affect the operation of the, otherwise does not affect the value of the number. Okay. So octal and hexadecimal. Coming to the octal, it will be having 8 symbols 0 to 7. We can form any octal number from the available numbers. Coming to the hexadecimal, it is having 0 to 9 and then followed by 8 to F. Okay. So it is having total symbols. Of course, this octal is having 0, 1, 2, 3, 4, 5, 6, 7. 0 starting from 0, that's why 8 symbols. Here 0 to 9 normally as a decimal number system, then followed by A, B, C, D, E and F. 10 plus 6, total 16. Okay, how many it is having? 8. This is having 2. That's why it's called binary. Okay, decimal 10. Okay, octal 8. Total symbols. Right? So these are the different number systems. So what is the number system basically? So it is representing a particular value, a particular quantity in the form of symbols. Here the symbols available are 10 symbols available. Using these 10 symbols, you can form any decimal number. Coming to the binary, it provides you 2 symbols. Using these 2 symbols, 0 and 1, you can form any binary number of any number of digits. Right? Coming to the octal, it is giving you 8 different symbols. Okay, these are different symbols. You can form any octal number from this 8 available symbols. Coming to the hexadecimal is giving you total 16 symbols. The combination of 16 in different form can be used to represent a hexadecimal number of any length. Any length, I mean any number of bits or digits can be there. Okay, this is about the number system. Okay. Each number system I will be taking in detail now. So our decimal number system now. We are having 10 symbols. Okay. So I'll just write it in the point wise about the decimal number system. Commonly used in daily life. In day-to-day life. It has 10 symbols, 0 to 9. Okay, it is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. It is having total 10 symbols, 0 to 9. Okay. Any decimal number can be formed from 0 to 9. Okay, any decimal number can be formed. So this is about the decimal number system, that we are practicing in our day-to-day life. Okay, because we have been practicing it for many years, so we are very familiar with it. And this is the number system we are taught from our early education. Okay? Right from the primary, we will start the numbers from 0, 1, 2, 3. Okay, so that is the number system we are all practicing, we are all comfortable with. Okay. Now the next number system is the binary number system, where I have told you that the binary number system uses two different symbols. The two symbols are 0 and 1. Okay. First thing you need to know here, it uses two symbols. And the two symbols are 0 and 1. Used in memory and almost all digital circuits. Or you can also say systems. All the digital systems use binary number system. Okay. So this binary number system is used in digital systems. We can take the most familiar example as computers. Okay. Right. So about this binary number system, we can also add some points. That is, when we are using the symbol 0 and 1, we can form the combination of 0 and 1 to form the binary numbers. Okay. So when you are using only one symbol, that is either 0 or 1, so that becomes a bit. Okay. 1 symbol used to represent any information. Okay, only one symbol, one binary symbol. Then it is called as bit. Okay, this bit is also called as binary digit. Binary digit, termed as BIT, bit. All these terms, bit And byte you must have heard in your day-to-day life, where you will be using the byte to represent the memory of your mobile, otherwise memory of your what we can say SD card or microchip and all. So only one bit, 0 or 1, only one binary digit. That one binary digit can be bit where we can see 0 or 1. The combination of the two is not taken as a bit, because bit means this one or this one. There can be only one binary digit, that is called as bit. Okay, 0 represents something and 1 represents something else. Okay, so this type of symbol can be used in the systems where you just need to show the true or false system. Okay, for example, one bit information. It is also information. 0 means something and 1 means something. For example, if you are using any alarm system, whenever the signal has raised, it will become 1. That means there is a condition for alarm to ring. And if there is the system is at 0, there is no instruction for the alarm to ring. Okay, so which is showing only two possibilities, yes or no, true or false type of representations can be used using the 0 and 1. Okay, it definitely conveys some information. So all these number systems, the group of numbers or the group of digits or binary digits, that is bits, is basically to convey some information. Here just a single bit can convey information, right? 0 may be false and where 1 may be true, right? So this is about the first definition, that is bit. Binary digit is called as bit where it can represent only one symbol, either 0 or 1. Okay, this is about bit. Now nibble. Okay, nibble. Group of 4 bits. Group of 4 bits. Now I have told you what is bit. Bit is single binary symbol, 0 or 1. Group of 4 means we can make a combination of any number of zeros and ones. That means I will give an example, that is 0, 1, 0, 1. This is one nibble because it is having how many bits? It is having 1, 2, 3, 4 bits. Okay, this is a nibble. Okay, group of 4 bits, that is binary digits. Group of 4 binary digits is called as what? Nibble. Okay, definitely this also represents some information. Okay, next, byte. Here byte means this is the most familiar group of binary digits, bits, we can say, because we use this in our data. Byte is a group of 8 binary digits or 8 bits. Okay, group of 8 bits is called as what? Byte, right? Next is word. Word is a specific number of symbols. Specific number of symbols that represent a quantity or information. So here there is no specific number of bits representation for a word. It conveys some information. It can be of any length. Okay, depends on the system. If a system operates on 32 bits, then it will be the word representation for that particular system. Okay, if a system works on 64 bits, then it will be the word length of that particular system. So word is not having any specific number representation. The number of bits is not specific in terms of word. It is the number of symbols that is used to represent some information. Okay, We can also see that two nibbles form a byte. Two nibbles are made to form a byte. Okay. So this is about the binary number system. I have also taken an example of nibble here. I will also write the example of a byte here. 4 plus 4, total 8. This is a example for what we can say a byte. That is the example for a nibble. Okay. This is the binary number system. This is all about the binary number system. Now we'll discuss the next type, that is the octal number system. Here we'll be just looking at the number system. It is not in detail for your syllabus. You have to focus on the three number systems, that is decimal, binary and hexadecimal. So I will just tell you the basic of the octal and then we will move to the hexadecimal number system. So about the octal number system, I have told you that the octal number system will be having how many? 8 symbols. The 8 symbols are 0 to 7. So from the 0 to 7, we can form any octal number. That means with the combination of 147 is there. So you cannot exceed 7. You cannot write a octal number using 8 and 9. So you cannot write 824. Here 8 becomes a invalid octal digit. Okay, otherwise invalid octal number. Right? So you can use only 0 to 7. Okay, we can use only 0 to 7. So we can form a number of the number as 126. This is a valid octal number. Okay. If I write 128, this becomes an invalid because it is not a octal symbol. 8 is not an octal symbol, 9 is not an octal symbol. So you can write the numbers only up to with if you want to write the number system of only one digit, then 0 to 7 you can write. If you want to write 2-digit numbers, then 0 to 7 you can write. If you want to write a 3-digit number, then you can write 0 to 777. Okay. Like it is with the binary decimal number system, that for 1 digit you can write 0 to 9. That means units place. Okay. If you want to write from for 2 digit, then you can start from 00 to 99. That is up to 99. That is the tens place. Okay. If you want to write it for 3 digits, you can start from all 3 zeros to all 3 nines. Okay. So like this, you can use the octal number system. So if any number is having or it is using a symbol of 8 and 9, then it is not a octal number. Then that becomes a decimal number. So when you want to form octal number, then you can only include the symbol 0 to 7 in that. Right? This is about octal number, which is using how many symbols? All that I will write now. Okay. So it uses 8 symbols, that is 0 to 7. That is 0 to 7. Okay. So how many total symbols it is having? It is having 8. Now moving to the Next type of number system which is very important is the hexadecimal. This octal number system is not in detail for your syllabus. Okay, now we are moving to the hexadecimal. The hexadecimal number system uses 16 symbols. It uses how many? 16 symbols. Okay, that is 0 to 9. Apart from 9, it also uses A to F. Okay. Right. So total 16 symbols it uses, and it the symbols are 0 to 9 and A to F. Okay. I will tell you now how to write the hexadecimal number starting with 0 to 9. Up to 9 it will write. After 9 it will start with A. Then it will be B. It will be C, D, E, and finally F. Right? So what happens here? 0 up to 0 to 9, it is the same. A means 10. B means 11. Decimal values. Decimal value 10, decimal value 11, decimal value 12, 13, 14, and 15. So this particular number system, that is the hexadecimal number system, is using what? Total 16 symbols starting from 0 to 9 makes 10. Remaining 6 are made from A, B, C, D, E, F. Right? So these are the 16 symbols. This is how we will write for single digit hexadecimal number. If we write 2-digit number, then we will write from 0 to 99. After 99, what happens? We will write up to FF. So basically, it is from 0 to FF. 0, 0, 0 to F, F, F. Okay. Like this, we will be writing the number system for hexadecimal. All detail about this will be studying while studying the conversion from one number system to another number system. Okay. So these are the number systems wherein we have seen the total number of symbols used and how important they are. Okay. So the importance and the total number of systems used in each number system we have seen here. Now we'll see some terms that are used in the number system. Okay. The first thing we'll be seeing is the base. Okay. Base. Okay. So what is base? It is the total number of symbols a number system has. Okay, it is the total number of symbols a number system has. So I will write the number systems for binary. How many it is having? 2. Decimal, how many it is having? 10. Okay. Octal, 8. Whereas hexadecimal, 16. Okay. It is the total number of symbols a number system has. Okay. Sorry. It is the total number of symbols a number system has. So binary number system is having 2 symbols, right? That is 0 and 1. Decimal number system is having 10 symbols, 0 to 9. Octal is having 8 symbols, that is 0 to 7. Hexa is having 0 to 9 plus A, B, C, D, E, F, total 16. So this is the base of a number system. So whenever you are representing any number, I will just write it here for your understanding. I will write a decimal number, binary number like this. I will place a base here. That means if I write like this means that it is a binary number system because we are representing the total numbers of symbols it is having as a base here. We are placing a base to this number. So it becomes a binary number. Moving to the decimal number, I will write a decimal number like this. I will write base 10. This symbolizes that, otherwise this simply indicates that this particular number is a decimal number system. Decimal number, okay? 125, okay? I will write 8. It simply indicates that the number I am looking at is a octal number, okay? Here 256 is a decimal number because it is having a base 10. It is a binary number because it is having a base 2, okay? 1, 5, 8, okay? A means 10 here, okay? So this number system, hexadecimal number system representation can have the alphabets A to F also, okay? So this we will write as 16, base 16 if we place here. This simply says that this is a hexadecimal number. So this is the base, okay? So this is the definition for base and how we will represent the base for different number system. Any binary number written with base 2 simply tells us that it is a binary number. Any number with base 10 indicates that it is a decimal number. Any number with base 8 indicates that it is an octal number. Any number with base 16 says that it is a hexadecimal number. See, this number in decimal becomes 1010. This number, if we write this just by changing the base, if I write a base 10, then becomes a number 1010. But if I place base 2, this becomes a binary number, and in binary this simply becomes 10. How it becomes a null, we'll be studying in detail, okay? So this is about the base. Base or radix. This is also called as radix. Next definition is radix point. Radix point. The point that separates the integer part and fractional part in a number. In a number, okay, is called as radix point. For example, I will take an example of binary number itself. The number is point. Okay, this is radix point. This is the integer value and this is the fractional part. The point that separates the two is called as radix point. Okay. So these are the two definitions. Next is place value or weight. All these questions could be asked for 1 marks to define base or to define the radix point. Otherwise, to define radix and radix point. Radix is nothing but the base itself. That is the total number of symbols a number system is having. Okay. The next definition is the place value, otherwise weight. Place value or weight. I will explain it with an example. I will write a decimal number. This is a decimal number. Here, each digit is having its place value. For example, 9 is having units place or ones place. Okay. 6, tens place. 8, hundreds. And thousands place. Okay. So this place value is having 10 to the power of 10 to the power of 0. This will be having the place value 10 to the power of 0. This will be having 10 to the power of 1. This will be having 10 to the power of 2. This will be having 10 to the power of 3. Okay. Thousands, hundreds, tens, and units. Likewise, each number system is having its own place value or weight. Each digit is having its own place value or weight. The place value of this is 1000. So 10 to the power of 3 into 5. What is the value there placed? Is 5. So what this will give you? 5000. Okay. Into 8. What it is going to give you? 800. Into, it is nothing but 8 into 100. It is nothing but 8 into 1000. Here it is 6. So you will write as 60. And into 1. Anything raised to 0 is 1. This gives you what value? 9. Okay. That's why it makes a total of 586. Each digit is having its place value. Units place, tens, hundreds, and thousands place. Okay. I will show the place value for each number system. Let's take an example of binary number. Okay. This is having the place value of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. That is nothing but 1, 2, 4, and 8. Okay. 1, 2, 4, and 8. So whatever value is placed here, we will simply multiply it. That is into 1, into 0, into 1, and into 1. So what value it is now? 1, 0, 4, and 8. So what total it makes? It makes 13. Okay. So this is the place value. See, this place value depends on the base. Right now we have studied about the base. Base is the total number of symbols it is having. So it is the rightmost bit is having base to the power of 0. The leftmost bit is having base to the power of 3. Okay, so 0, 1, 2, 3. Base to the power we will place. And equivalent value we will simply multiply with the symbol it is having at that place value or position. Same way here in the binary it is happening. Okay. So this is about the place value or weight. Right? Likewise, we can write different numbers of binary. And about the octal and the hexadecimal now. I will take an example of number 2, 5, and 4. This is having 8 to the power. This will be having 8 to the power of 1. And this is, sorry. Eight to the power of 2, 8 square. And followed by the different numbers. So it will give you a place value of it. So you will simply write the values into 4, into 5 and into 2. Okay. So this is going to give you into 1 only, so 4. So it is going to give you 40. Okay. And this is going to give you 8 square is 64. 64 into 2, 128. Okay. So 128 plus 40. Sorry. Eight into 8 is going to give you 64 and the value is 2. Okay. 256. This is going to be 40 and this will be, I'll just take the example of 54 here. Just write the calculation in simpler way. So this is going to make you for the octal number system, I'm going to write it now. Where the base is 8. Okay. Sorry, I'm taking a simple example. 8 to the power of 0 and 8 to the power of 1 into 5, which is just a 5, and 2, which will be just a 16. Okay, that will make what? 11 and 1, which is going to make 21. So I'm just converting it, right? So in the conversion, what happens if we are going to write it 25 in terms of octal, it will become 21. Okay. Next, hexadecimal number system. In hexadecimal, we'll be using different place values. For example, if we are using 1 and f, I will take a very simple example here. Okay, I'll be computing it. So f is having 16 to the power of 0 into 15. Okay, and 16 into 1. Okay, so this is nothing but 15 plus 16. F is nothing but 15. 15 into 1 is 15. Okay, 16 into 1 is just 16. So this is going to give you 31. Okay, 31 means the decimal equivalent value. So 1f when I am writing, that means nothing but 31 in the decimal form. Okay, so this is the value. Like the binary value is having 13. This particular value is having 13 in decimal. This particular value will be having 31 in decimal form. Okay, this is about the weight position. So that was the same for the octal also, which is having a decimal value. When we are using 25, the decimal value will be 21. Okay. This is about the position value, otherwise the weight of the number systems, right? So we have discussed about the definition, etc., and also we have studied about the what we can say place value. For the place value, where we have computed the value that represents the equivalent decimal number. For the binary we have seen, for the octal we have seen. In the octal we have seen that 25. When we are representing 25 in octal, that is nothing but 21 in decimal. Okay. And also we have seen for the hexadecimal that 1f is nothing but 31. Okay, when we are converting it, the value that we are getting will be in terms of decimal there. Okay, so we have discussed about the number systems a lot. Tomorrow I'll be covering with the conversions. That means some in the place value we have seen some of the parts also here. That in detail conversion from one type of number system into other and all we will be studying here. Thank you.